Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 1.6. So the statement is determine the normal force, shear force and moment at section through point C. Take P is equal to 8 kilonewton. So you have to find the internal loading, for example, normal force, shear force and moment at this point. For this we will have to draw the free body diagram of this structures that is given. So why we are going to draw the free body diagram? In order to find the reaction forces at point A. So let's draw the free body diagram for this figure. So if you remove this support at point A, there will be a normal force at point A. Clear? That is normal force at point A, and there will be horizontal load at point A. Let this force is AY and this force is AX, and there is a tension in this rope, that is, if I represent it over here by T, so it will be this T. Clear? Rest all the things are same. If you want to draw the free body diagram, just remove that, and in this rope there will be a tension, and at point A there is support reactions AY and AX. So let's move further to find the support reactions. So support reactions are AY and AX. We will take the moment, sum of all moment about point A is equal to 0 and take the counterclockwise as positive. Clear? Now you can see we are going to take the moment about point A. So the force which is producing moment about point A is P. Clear? And this P is given as 8 kilonewton, and this is producing counterclockwise movement. So 8 into perpendicular distance is 0.75 plus 0.75 plus 0.75, and it is equal to 2.25. The other force that is producing movement is this tension in the rope about point A. Clear? And that is equal to T into perpendicular distance is, you can see the perpendicular distance from this point till this point. This is 0.6. Why? Because this is 0.5 and this is the diameter of this pulley. So half of the radius will be equal to, this is the radius of this pulley. So 0.5 plus 0.1 is equal to 0.6. So the perpendicular distance is 0.6. Since it is producing clockwise movement, so that will be equal to negative, and their sum must be equal to 0. From here, when you calculate this, you will get the tension in the rope, and this tension is equal to 30 kilonewton. Once you have this tension, you can also use the other equilibrium condition, that sum of all forces along x direction is equal to 0, and in this direction it will be positive. So now you can see in horizontal direction there is two forces, one is AX and other is tension T. So their sum must be equal to 0. So AX is in negative direction, so it will be minus AX, and tension is in positive direction, so it will be plus T, and T is equal to 30 kilonewton. Their sum must be equal to 0. So it means that AX is equal to 13 kilonewton. Now we will find the other reaction force by using the equilibrium condition, that sum of all force along y direction is equal to 0 and upward force is taken as positive. So you can see the upward force is AY and P. So P is downward, so it will be minus, P value is 8 kilonewton, so minus 8, and AY is upward, is equal to 0. So it means that AY is equal to 8 kilonewton. Now we have find out the reaction supports at point A. You can use this member AC and you can draw the free body diagram. That this is this member, this is point A and this is point C where you want to find the internal loading. So for normal force it will be NC, clear. There will be a shear force when you cut it, and this shear force is this is upward, so it is VC, and there will be a movement, reaction movement at this point C, and that will be MC. So here at point A, AX is equal to 30 kilonewton and AY is given as 8 kilonewton, and this distance is also given, that is 0.75. Now the problem becomes very simple. You have to just apply the equilibrium condition in order to find the internal loading at point C. So equation of equilibrium for point C, equation of equilibrium for point C is sum of all forces along x direction is equal to 0, clear. So you can see here there is two forces, one is 30 kilonewton, another is NC. So minus NC minus 30 kilonewton is equal to 0, so implies that NC is equal to 30, NC is equal to minus 30 kilonewton. Again you can see here the NC direction is in negative and the value of NC is also negative, so it means that our assumed direction is wrong, clear. We will move further in order to find the other values. Sum of all force along y direction is equal to 0, and that is used to find the shear force. Now there is shear force VC is acting upward, and there is a load of 8 kilonewton that is also acting upward. So their sum must be equal to 0, so it means that VC is equal to minus 8 kilonewton. Now VC is taken as upward while the value is negative, so it means our assumed direction was wrong and you have to take the shear force in lower direction, clear. For finding the moment, we will take sum of all movement about point C is equal to 0 and counterclockwise as positive. So at point C there is external movement MC, that is clockwise, so it will be negative. The force that is producing movement about point C is 8 kilonewton, clear. So 8 kilonewton and perpendicular distance is 0.75 and it is producing counterclockwise, so it will be positive. So 8 into 0.75, when their sum must be equal to 0. So when you solve it for finding MC, so MC will be equal to 6 kilonewton into meter. Again this is 6 kilonewton into meter, and that will be in clockwise direction. So this is how we find out the internal loading. This is normal stress force, this is the shear force, and this is the moment, that is internal loading at point C. I hope you have enjoyed the video. Thank you for watching and supporting me.